Hello everyone, my name is Kshitija Satish Patankar. I'm going to demonstrate the system which I have built, that is multiple disease prediction system using machine learning. So, what is a system? The system, when we built an application, it consists of two parts like front end and the back end. So, before moving to the system which I have built, first of all, I would like to explain what is the front end part and back end part for the freshers who are the new first year going students who don't have an idea about it. So let's move to the basic concepts first. So many times we are confused, like what is the front end part and what is the back end part. So let's get a clear idea. First, what is the front end? The front end is the part of the website users can see and interact with, such as the graphical user interface, that is GUI, and the command line, including the design, navigating menus, text, images, videos, etc. And the front end languages, like what languages we use for the front end is HTML, JavaScript, CSS, and more. Like here are the symbols of them. Then let's see the backend part. The backend is a part of the website users cannot see and interact with. Everything that happens in the background can be attributed to as backend. Like front end is like the user interface. For example, we are doing the online shopping on Amazon. So whatever we are ordering on that website or application, that is the front end part. Like we can interact with it. But how that application was built, what was done at the backend using which languages is the backend part. Backend languages are PHP, CPP, Java, Python, and many more. Here are the symbols. Now, let's move to the system which I have built. Yes. So my system is multiple disease prediction system. So why this system I have choose to build? Let's take a look. So what's the main issue or the problem statement? Many of the existing machine learning models for healthcare analysis are concentrating on one disease per analysis. Like till now, many of the systems considers only the one disease. So for example, first is for like diabetes analysis, one for heart analysis, one for lung diseases, like that. If a user wants to predict more than one disease, he or she has to go to different sites, like they need to navigate to one site or more. There is no common system where one analysis can perform more than one disease prediction. Some of the models have lower accuracy, which can seriously affect patients' health. So, due to these issues, I thought that the multiple disease prediction system will be a good alternative and will be more effective. Now, about the project. This web app, I have developed a web app which is developed using the Python Streamlit library. Like in the backend, I have used the Python language, and for deploying my system, I have used the Streamlit Python library. The models used to predict the diseases were trained on large data set. I have done the system of three diseases, considering three diseases. We can do of more diseases, but here I have considered only three diseases, like the diabetes, heart disease prediction, and Parkinson's disease. So the models used to predict the diseases were trained on large data set. I'll show you the data set. The web app can predict following diseases, which I have mentioned as follows. Now, let's take a look about the Streamlit library, which I have used for deploying the application. Streamlit is an open source app framework in Python language. It helps us create web apps for data science and machine learning in a short time. It is compatible with major Python libraries such as scikit-learn, keras, pytorch, numpy, pandas, matplotlib, and etc. Like Streamlit is an open source app framework in Python. It is part of a Python language. Python language provides a framework for deploying an application. Then Streamlit is a free and open source framework to rapidly build and share beautiful machine learning and data science web apps. I have choose Streamlit because I have never tried. I have done the website or web application before in HTML language, CSS, like using HTML, CSS. But Streamlit was new for me, and it is kind of easy. Streamlit is mainly used for data science and machine learning for deploying the applications. It is a Python based library specifically designed for machine learning engineers. Yes. So what is the procedure I have followed? First step is to import the necessary libraries and the data set. Then split the data into features and target variables. Then split the data into training and testing sets. Train the model on the training data. Save the model using the pickle module. Use Streamlit to create a web application that allows users to input their own data and make predictions using the saved model. Include a button in the application to process the input and make predictions. This is the procedure, these are the steps which I have followed, which I'll demonstrate you step by step, showing all the dataset which I have used, from where I have taken the dataset, then what platform I have used to launch the Python, or how I have installed the Streamlit libraries and all. I will demonstrate step by step. Okay, now coming towards the algorithms, like in the backend, I have used Python language, but for training the model, for deploying the application, we need like algorithms in machine learning. There are various algorithms in machine learning. So, out of them, I have used two machine learning algorithms. That is, the first one is the SVM, that is support vector machine. Now, what is SVM? Support vector machine is one of the most popular supervised learning algorithms, which is used for classification as well as regression problems. Now, here also we will be classifying the diseases, like by giving some parameters, whether the particular person is diabetic or not. Like, we'll classify it. So I have used the support vector machine. The goal of the SVM algorithm is to create the best line or decision boundary that can segregate n-dimensional space into classes, so that we can easily put the new data point in the correct category in the future. SVM is the most effective algorithm to classify. So I've used the SVM algorithm. I'll demonstrate you how I have trained the model using the SVM algorithm. And the next is the logistic regression. Logistic regression is one of the most popular machine learning algorithms, which comes under the supervised learning technique only. It is used for predicting the categorical dependent variable using a given set of independent variables. Like, it is used for predicting the categorical data. Logistic regression is a significant machine learning algorithm because it has the ability to provide probabilities and classify new data using continuous and discrete data sets. Now, this is the implementation part. Like, this is the website or web application which will look after we do all the procedures and then we deploy the application or the system. The first one was for the diabetes prediction. Like this I've done for the diabetes, heart disease, and Parkinson's. Okay. Now, what is the application? With the advancement in technologies and mobile phones being the most used user friendly device, an application that provides a prediction of the most caused lifestyle diseases like diabetes, heart disease, and other diseases. Disease predictor allows you to make important predictions about an ongoing and unknown disease with a few pieces of information like symptoms and diagnostic reports. It also helps you to have an in depth knowledge of the symptoms, causes, and other important factors for future reference. Like, every time a patient cannot approach a doctor, or for example, we can take of the COVID situation, patients were not even able to go to the doctor or hospital. So, by deploying this application, by if a patient provides some parameters about the symptoms they are having, if they put the parameters, give input to the system, then the system predicts whether the person is diabetic or having the heart problem or other disease. Now, uh, now I would like to show you the backend part which I have done. So, this is the Jupyter notebook. So, Jupyter notebook is included in the Anaconda navigator. Now, what is the Anaconda navigator? Yes. So, this is the Anaconda navigator. Anaconda navigator acts like a platform for launching the various applications. Now, here we can see the data spell, the Qt console, Spyder, data lore, Oracle, then a PyCharm, Jupyter Lab. See, this is the one Jupyter notebook which I have used for the coding part of the Python. So this is the Anaconda Navigator. We can launch the various applications, like we can install libraries or set up various environments. So this is, from this Anaconda Navigator, I have launched the Jupyter Notebook. Now I'll take you to the Jupyter Notebook. Yeah. So this is the Jupyter notebook on which I have done the Python coding. So this first is for the diabetes prediction. I have done the coding part. Then this is for the heart disease prediction, and this is for the Parkinson's prediction. So for all the three diseases, I have done the same operations. So first we'll look for the diabetes disease prediction. So first step is for the importing the dependencies. Importing the dependencies means like the importing the necessary libraries we need in the Python for performing the various tasks. Like for example, importing the NumPy as NP. NumPy Python library is used for the like the arrays in the data set or for performing the proper operations. Like now pandas library is used for the data manipulation. Now this now sklearn here is used for the training the model. Now these are the important libraries which we have imported first. This is the first step. Then next step is the data collection and analysis. Like now, as I mentioned, I have used the large data set. Now before going to the next step, I would like to show you the data sets. So this is the data set of the diabetes prediction, like the patients. These are the number of patients. These are the parameters like number of pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, and etc. So this data set we can take from the most well-known. Give me a minute. Yes. So this is the site. Kaggle is the well-known site for the downloading the dataset. We get various number of dataset. For example, I need the dataset for heart disease. So we get number of datasets here, and we can download the dataset. Now let's look here. This is the dataset for the heart disease classification. So here they give the information about it, like what are the parameters the dataset includes. So from here only I have downloaded the dataset of heart disease, the diabetes, and the Parkinson's. Now let's go towards our next step. So this is of the diabetes disease prediction. So next step is of the data collection and analysis. Now the first step is the dataset which we have downloaded, loading the diabetes dataset. So first we download the dataset, and here we give the path and read the dataset. Now the next step is the printing the first 5 rows of the dataset. Then we count the number of rows and columns in the dataset. By this we get the total count of number of rows and columns in the dataset. Then the next step is statistical measure of the data. Like it describes the whole data set, like what is the what is the count, mean, minimum values of the various parameters of pregnant number of pregnancies, glucose, blood pressure, and etc. Now, the next step is checking the distribution of the target variable. Like in this data set, we will have two patients. Like one is the diabetic one, and second one is the non-diabetic one. So we get the total count. Here, 0 stands for non-diabetic person, 1 stands for diabetic person. So non-diabetic person in total of 500 in the given data set, and the diabetic are 268. Now the next step is like we take the mean of the whole like whatever we have calculated here, the count, the diabetic and non-diabetic, we take the mean of that. Then the next step is separating the data and the labels. Now here will we like these are the parameters like which we need for in the system for giving the input, and the last column which we'll see here is the outcome. So we'll separate that. Like outcome is like it predicts, it shows whether the person is diabetic or non-diabetic. So for now we don't need it because the system will automatically predict it. So we'll just separate the data and the labels. Now the next step is performing the train test split. Why we perform the train test split? Because we need to train the model. So first we'll perform the train test split. Then after like train test split is like that, we divide the dataset into training dataset and testing dataset. Next is the training the model. So for here I have used the algorithm I have used is the SVM algorithm, like that is support vector machine, which I have explained earlier. Then we'll do the model evaluation and we'll remove the accuracy score on the training data first. Then we'll remove the accuracy score on the test data, like it predicts the score, because for prediction we need the accuracy. So here we'll do the calculate the accuracy score. Then making a predictive system, like this is the input data, like this is the input data of one person. So we'll uh, now in that we'll change the input data to numpy array, because the system should understand, like we and we if we give input data of one person, then the system should understand. If we give the data of another person, the system should detect it and then predict the same. So we again reshape the array as we are predicting for one instance. If we the system should come to know, so we are reshaping the array by using the if else loop. Here the if the prediction is 0, the person is non-diabetic, and if the otherwise the person is diabetic. Now, saving the train model. Now, whatever Python coding we are doing here, whatever the model we are training here, we need to save it so that we deploy it using the Streamlit library. So for this, the most important library or the model is the pickle. This pickle is used for saving the train model. So we save this file using the .sav, so that we upload it on the while deploying the application. Now loading the same saved model, and then whatever we have done here for making a predictive system, we'll do it while saving the model. And here now we get the number of parameters, like these why we need these parameters, because while deploying the system, only these parameters the user will can see on that particular page. So to make it simple and easy, this operation is performed. And in similar way have done for the heart disease prediction and Parkinson's prediction. Same operations I have used, just the differences of the algorithms. So now here for diabetes, I have used the SVM algorithm, and here I have used the logistic regression, because logistic regression is used for categorizing the data set. So here I have used the logistic regression, but all the operations in the all the three diseases are the same. You can take a look, like the importing the libraries, data collection and pre-processing, then training the model, performing the train test split, then taking the accuracy. Same, all the operations are same, just the algorithms have used are different. Now the same goes with the Parkinson's disease prediction system. Same operations I have performed, just here I have used the SVM algorithm. Yes, I've used the support vector machine algorithm here in Parkinson's. Otherwise, all the operations are the same. Now, we will save all these three models by .sav using the by saving the model. As you can see here, we have done the separate code for saving the train model, and we have saved it using the .sav file. Now, for this, I have used the Jupyter notebook for performing the Python code, which is the backend part. Now, this is only the backend part. Now, I need to deploy the system. As you can see here, this is my UI. So to deploy the system, now I will deploy the files which I have saved, the code which I have saved onto the Spyder platform. Now I'll show you what is the Spyder platform. So we'll go to Anaconda again. So this is the Spyder. So here it is clearly mentioned, the scientific Python development environment. Spyder stands for Scientific Python Development Environment, which is a powerful Python IDE with advanced editing, interactive testing, debugging, and introspection features. Now I'll launch this. It will take some time. Now I have whatever the models I have saved, I have again uploaded on the Spyder IDE, and then while I have executed on the Spyder IDE, and then uh, I have used the Spyder IDE because the connection, like the front end and back end, should be connected so that the application will work, right? So I have used the Spyder IDE for the connection and for the deploying purpose. Yes. So this is my, I have saved it by multiple disease prediction. So here also I have imported the pickle first, then the main two libraries, like that I have told you for deploying the application I'm going to use. For front end I'm going to use Streamlit library, which is a Python library. So then importing the Streamlit library and then the Streamlit option menu. Why Streamlit option menu? As you can see here, these are the options, like the diabetes prediction, disease prediction, and the Parkinson's prediction. So if the user wants the heart disease, he or she can navigate through heart disease or the Parkinson's or the disease prediction. So now the models which I've saved, first I will load the following models, then I'll create the sidebar for navigation. Then this is the code for the sidebar, like whatever the sidebar menus I was having, this is the code for the sidebar for navigation. Now we need to create three pages for the diabetes prediction, heart disease prediction, and the Parkinson's disease prediction. So first I have created the prediction page for the diabetes. So first giving the page title, then these are the various parameters which will appear on the page so that the user can give the input. So this is the number of pregnancies, glucose, blood pressure, and etc. Then at the end we need to create a button. When the user gives input values to the parameters, there should be a button so that the system will predict. So this is the creating a button for the prediction. In the similar manner I have done for the heart disease prediction. Same. The page title, then the number of parameters, then the code for prediction, and the creating a button for prediction. And after creating all this, I have saved this file. I have saved this file. So this is the folder. This is the folder in which I have kept all my data sets: diabetes, heart, and Parkinson's. So this is the Python files, like the which I have done the Python coding. This is of the diabetes, heart, and Parkinson's, and this is the now whatever I've shown you of the this file I have saved here, which is the multiple disease predict. Now we need to deploy it. Now we have used here Streamlit library, right? So this library will deploy my application, will see it how it deploys. Now when I save it, what we need to do is the this path. Now I'll show you what command we need to put in the command prompt to run the to deploy the application. So as we are using the Streamlit library, the command will be streamlit run, and the path will be where my file is saved. Like whatever I have done on the Spyder IDE, that path I need to give. Now where will give this path? Now for that, in when we go in the environments, I have created one machine learning environment for my project. So by going here, if we go on open terminal, the terminal opens, and I'll just run this command. Now here the message occurs, you can now view your Streamlit app. So automatically my app will be open, like the website which I have created, it's running. So this is what we have created by doing all the three. Like I have done prediction for diabetes prediction, heart disease prediction. See, now this is my project, multiple disease prediction system. This is the sidebar. See, we can navigate through it. So this is the first page. Diabetes prediction using ML, then heart disease prediction using ML, and Parkinson's prediction using ML. So these are all the parameters, and here the button is there. Like the system will predict whether the person is diabetic or not. Now we'll give the input values from the dataset itself. So this is for the diabetes. So we'll give. So we'll input the values like for number of pregnancies 6, the glucose level was 148, then the 72 blood pressure value, then the skin thickness value was 35, then insulin was 0, BMI value is 33.6, then 0.627 is the diabetes pedigree function value, and the age is 50 of the particular person. Now, when we enter all the input values of the parameters, we'll click on this button and the person is diabetic with the prediction. Now for we'll cross check it. Now this is the outcome. While explaining you the Python code, I explained we'll separate the label and outcome. So outcome is nothing but the 1 and 0 values. 1 and 0 value stands for whether the person is diabetic or not. Now we got the 1. Now what the 1 indicates, the person is diabetic, and 0 indicates the person is non-diabetic. So here we have got the prediction. Similarly, we can do it for heart prediction and Parkinson's predictions. So this is my uh, system which I have uh, built, and I have done for three diseases. In similar manner, we can do it for many diseases and number of diseases. And yeah, so this is the only, like the multiple disease prediction system was mostly applicable in the COVID system. Like it should have been applicable in the COVID crisis, because at that time the situation was worst and the patients were afraid to go to the hospital. So if the person is sick, then this system could have helped, like whether the person is deceased or not. So this is the system which I have built. Thank you.